Oxygen, sulfur, selenium, tellurium, polonium, and livermorium contain in group 16 elements in the periodic table. They are sometimes called as a chalcogen. This chalcogen is the word derived from the Greek word brass and point to association of sulfur and its congeners with copper. Most of the copper materials contain either oxygen or sulfur, and frequently the other members of the group. So, due to the reaction with coppers, its name chalcogen will comes. This is what about the group 16 elements. Generally, these group 16 elements are called as a representative elements, and they belongs to oxygen family. Now we'll see about occurrence. Oxygen is the most abundant of all the elements on the earth. Oxygen form about 46.6% by mass of the earth crust. Dry air contain 20.946% oxygen by volume. Not only in this, we have water also, water contain oxygen. So altogether, from that different sources of oxygen, we get it 46.6 by mass. However, the abundance of sulfur in the earth crust is only 0.03 to 0.1%. Combined sulfur exists as in the form of sulfates and sulfides. Some examples of that is galena, that is PBS, zinc blending, that is zinc sulfide, copper pyrite, that is about the sulfide ores. For the sulfate ores, we have gypsum, epsom salt, and barytes. Gypsum means CaSO4, 2 times of H2O, that is sulfate. And like this one, your epsom salt means MgSO4, 7 times of H2O, it is epsom salt. And baryte means BaSO4, that is baryte. Now, selenium and tellurium are found in the form of metal selenoids or tellurides in sulfide ore. Polonium occurs in nature as a decay product of thorium or uranium minerals. Livermorium is a synthetic radioactive element having the symbol Lb and atomic number 116. It has a very short half-life period, that is about only a very few fractions of the second. Due to the small half-life period, its study is limited. However, this livermorium took an important in atomic and physical properties of other elements of the group 16 with their electronic configurations. Now we have seen the electronic configuration in the table 7.6. In the table 7.6, we have seen that oxygen, atomic number 8, and atomic mass 16, electronic configuration 2s2, 2p4, and covalent radius, that is ionic radius 1, covalent radius 66, ionic radius 140, electron gain enthalpy minus 141 kilojoules per mole, then ionization enthalpy 1314 kilojoules per mole, electronegativity 3.50, density 1.32, melting point 55, boiling point 90, different oxidation state, that is minus 2, plus 2, minus 2, minus 1, plus 1, plus 2. These are the oxidation state of oxygen. Like this, sulfur also you can see it in the table itself. This is what about the physical properties of group 16 elements. Now we will see about the electronic configuration. As we know that this group 16 elements have 6 valence electrons in their electronic configuration and have general electronic configuration of NS2 NP4. This is the outermost general electronic configuration of this group 16 elements. Now we will see about the atomic and ionic radii. Due to the increase in the number of shells, atomic and ionic radii increases from top to bottom in the group. Increases from top to bottom in the group. The size of oxygen atom is, however, exceptionally small. As we know that when we move down the group, generally atomic size increase due to the addition of new shells for the incoming electrons. So when we move down the group, size gradually increase, thereby electronegativity gradually decreases and metallic character gradually increases. This is what we have seen in the atomic size. Now we will see about the ionization enthalpy. Ionization enthalpy decrease down the group. It is due to the increase in size. However, elements of this group have lower ionization enthalpy value as compared to those of the group 15 elements in the corresponding period, because group 15 elements have half-filled p orbitals. Half-filled p orbitals have more stable than partially filled p orbitals in case of group 16. Due to the presence of extra stability in group 15 elements, it is difficult to remove electrons. The energy required to remove an electron from its stable gaseous atoms is called as a ionization enthalpy. So, ionization enthalpy decreases down the group because of increase in size when we move down the group. Next, we will go to the electron gain enthalpy. Electron gain enthalpy is the energy required to add an excess electron to the stable gaseous atoms that we call as a electron gain enthalpy. Because in oxygen we have a compact structures because of half-filled, due to that oxygen have least negative electron gain enthalpy than the sulfur. This point is very important. However, from sulfur onwards, the value again become less negative up to polonium. This is because of increase in size. Now we will go to the electronegativity. Next to fluorine, oxygen has the highest electronegativity value among the elements within the group. Electronegativity decrease with increase in atomic number. As with increase in atomic number, size gradually increases. Hence, the force of attractions between the nucleus and the added electrons gradually decrease due to the decrease in effective nuclear charge. So, thereby metallic character increases from oxygen to polonium. This is what we have. Now, let us see about the physical properties. Physical properties of these elements. Group 16 elements. Among the group 16 elements, oxygen and sulfurs are non-metal, selenium and tellurium are metalloids, whereas polonium is a metal. Polonium is a radioactive, having the short half-life period of 13.8 days. All these elements exhibit allotropy. The melting and boiling point increases with increase in the atomic number down the group. The large difference between the melting and boiling point of oxygen and sulfur can be explained due to their atomicity. In case of oxygen, oxygen is diatomic, whereas S8 is of polyatomic. Thereby, the boiling and melting point of your oxygen is lower than that of the sulfur. As atomicity decrease means the binding force gradually decreases, which make less in atom melting and the boiling point in case of oxygen. Now we will go to the chemical properties, oxidation state and trend in chemical reactivity. We'll discuss this one. The elements of group 16 elements, the elements of group 16 elements shows various oxidation state. Out of that, -2 oxidation state decreases down the group. The stability of -2 oxidation state decreases down the group. Polonium shows hardly -2 oxidation state since electronegativity of oxygen is very high. It shows only negative oxidation state -2. In case of OF2, the oxidation state is of +2. So we can ask, name the compound in which oxygen shows +2 oxidation state. That is OF2. You need to by heart this one. This was already in the board exam. Other elements of the group exhibit +2, +4, +6 oxidation state. But +4 and +6 oxidation state are more common oxidation state in these elements. Sulfur, selenium, tellurium usually shows +4 oxidation state in their compound with oxygen. Whereas in case with the fluorine, it will show +6 oxidation state. So we can ask, when does group 16 element shows +4 oxidation state? In his compound, the group 16 element shows +6 oxidation state. Your answer is, with oxygen it will form +4 oxidation state. With fluorine it will form +6 oxidation state. The +6 oxidation state gradually decreases down the group, and the stability of +4 oxidation state increases. This is due to inert PR effect. Bonding of +4 and +6 oxidation state is generally covalent in nature. So we can ask this part also for the 1 marks. This part means the stability of +6 oxidation state decrease down the group, whereas stability of +4 oxidation state increase down the group. Why? Your answer is due to inert PR effect. What is the nature of bond in the compound? Like this one we can ask, in the compound means that you need to find out the oxidation state of the metal. If the oxidation state is +4 or +6, that is covalent. If it is of -2 or +2, then it is of ionic. So based on that, you can easily find out the nature of bond present in the species. So this question is also important. Now we'll go to the anomalous behavior of oxygen. As we know that if the species have very small in size, then it will show some anomalous properties. So anomalous properties of an element is because of smaller size and high electronegativity. This is the reason for why water have high melting point as compared to H2S. So the answer of this question, we can ask why. The answer of this question is that in case of water, oxygen is highly electronegative, thereby it can easily form hydrogen bonding, and whereas in case of H2S, it cannot form hydrogen bonding. Due to the presence of hydrogen bonding in water, water have high melting point as compared to H2S. H2S have only covalent bond. Next, we can ask another question. The covalency of oxygen is 4, whereas other members have more than 4 covalency. Why? The answer of this question is due to the absence of d orbital in oxygen, its covalency limit up to 4, whereas the other elements exceed more than 4, that is up to +6. It can, other element can exhibit. So like this is your answer. Now we'll go to the reactivity with hydrogen. All these elements of group 16 elements form hydrides of H2E type, where E is the elements. Some properties of hydrides are in your table 7.7, which we will not discuss. Just you can see it yourself later on. The acidic character increases from H2O to H2Te. The increase in acidic character is explained in terms of decrease in bond enthalpy for the dissociation of Ice bond down the group. This also we can ask as a question. The acidic character of group 16 element increases from H2O to H2Te. Give reason. Your answer is due to the decrease in bond enthalpy for the dissociation of Ice bond down the group. That means the Ice bond enthalpy gradually decreases when we move down the group due to the increase of size of E. This is your answer. Owing to the decrease in the enthalpy for the dissociation of Ice bond down the group, the thermal stability of hydrides also decrease from H2O to H2PO. So this also we can ask as a question. So like this, you need to understand it. All the hydride except water possess reducing property, and this character increases from H2S to H2Te. That means the reducing properties of hydrides of group 16 element gradually increases from H2S to H2Te. So we can ask, compare the reducing properties of the following hydride: H2S, H2Se, H2Te. So you need to write H2Te is the biggest one, next is H2Se, next is H2S. Like this you need to write it. This is what about the reactivity with hydrogen. So in the reactivity with hydrogen we can ask three types of question. One is about the acidity, another one is about the thermal stability, the third one is about the reducing property. So you need to read it properly. Now we'll go to the reactivity with oxygen. All these elements from oxide, all these elements from oxide of EO2 and EO3 type, where E is the elements. Ozone and sulfur dioxide are gases, while selenium dioxide is solid. Reducing properties of dioxide decreases from SO2 to TeO2. SO2 is reducing while TeO2 is oxidizing agent. So here also we can ask about the comparison between the reducing properties of oxides of these elements. Beside EO2 type, sulfur, selenium, tellurium also form EO3 oxides. Both the type of oxides are acidic in nature. So all the oxides of group 16 elements are of acidic in nature. Now let us see about the reactivity towards halogen. Elements of group 16 form a large number of halide, that is EX6, EX4, EX2, where E is the element and X is the halogen. The stability of halide decreases from fluorine to fluorine highest, then chlorine, then Br, then I minus. This is because of difference in the size, and or we can say difference of electronegativity. Out of this you can say any answer. Among the hexa halides or hexafluorides are only stable halides. All hexafluorides are gases in nature. They have octahedral structures. SF6 is exceptionally stable for steric region. So we can ask, among the halides of sulfur, which one is more stable and why? Your answer is SF6, because of less steric effect. You can say less steric effect means electron repulsion is less in case of SF6. SF4 is a gas, SEF4 is a liquid, TEF4 is a solid, while fluorides having sp3 dehybridization and thus have a trigonal bipyramidal structure in which one of the equatorial position is occupied by a lone pair of electrons. The geometry is also regarded as a seesaw geometry. All elements except oxygen form dichlorides and dibromides. These dihalides are formed by sp3 hybridization and thus tetrahedral structures. The well-known monohalides are dimeric in nature. Well-known dihalides are dimeric in nature. Example are S2F2, S2Cl2, S2Br2, SeCl2, Se2Br2. The dimeric halide undergo disproportionation reaction. So this disproportionation reaction is also, you need to understand it. And all the questions, textual questions, which I have already answered in the class. Say, list out the important sources of sulfur. So you can write the ores which we have already discussed. There is galena, this and that, which we have already discussed. Write the order of thermal stability of the hydride of group 16. As we have already discussed that for the thermal stability decreases from H2O to H2PO. You need to write that one. And why is water is a liquid, whereas H2S is a gas? So in case of water, we have hydrogen bonding, and whereas H2S cannot form hydrogen bonding. Due to that, the force is more, and hence water acts as a liquid, whereas H2S acts as a gas. This is what we have discussed for today. Thank you.